All right, so this is section 8.4, which is a really smooth transition from 8.3. In 8.3, we're adding rational expressions. In 8.4, we're subtracting, which the only thing that's really different, essentially, is that sometimes we're going to have to distribute that negative sign. Okay, so here in problem number 7, again, this is the packet that we're still working through. And this one, we look to see, do we have common denominators? And we do. Okay, so that is the x squared minus 4. Just to make it a little bit easier to see later on, I'm going to go ahead and put the factored version, which is the difference of squares. So I'm going to have x plus 2 times the quantity x minus 2. And on the top, we just can combine our numerators. So we have x minus 2. Now, do you see anything that we can cancel out? Yeah, that x minus 2, right? Because that whole quantity, x minus 2, will cancel on the top and on the bottom, leaving me with an x plus 2 on the bottom. A lot of people, they try to tell me this. Let me show you. They say, well, that x minus 2 went away, so all I have left is just x plus 2. That's not the case, though, okay? Say if we had, let me try to come up with a side example. What if I had... I'm just going to put in real numbers so that you can see it a little bit easier. What if I had 5 minus 2 over, let's just say, I'm just totally making this up. Okay, 3 times, let's go with a negative 2 to try to make it look the same, okay? So if you were to actually simplify this the correct way, oh wait, let's go a little bit different. I'm liking that 3. Let's just say times 5 minus 2. So if we were to actually do this using order of operations, we would have 3 over this 5 minus 2 would be 3 times 3 is 9. We'd get 1/3, right? So say now, like how people tell me that the thing cancels on the top and on the bottom, leaving with x plus 2. That would be like if in this problem, if you're like, well, if I canceled the top and the bottom that matched, my answer would be 3. Which is not true because there is still that 1 up top, right? So just like over here, let me write this in. There is still a little 1 here. So my final answer is actually 1 over that x plus 2, okay? So just be aware of that when you cancel things top and bottom and you think that you have nothing left on the top, it doesn't mean that it totally went away. It's just that you got rid of that factor and that 1 still remains, okay? Hopefully that makes sense. Go ahead and try this number 8. Just do the very first step and then hit play, okay? Because I don't want you to do too much work heading off in the wrong direction. So just do the very first step of rewrite it with the common denominator, which it already has, and then you're going to have to do something with that negative. So try to figure out what you're going to do and then hit play when you're ready. Okay, so our common denominator is that x plus 4, so we don't have to do anything there. Now, if we combine the top, a lot of people just tell me that it's this. They just say x squared minus 3x plus 28. But this minus here, this guy, is saying that we want to subtract the entire 3x and 28. So you have to subtract the entire thing. So to show me subtracting the entire thing, we're going to put that in parentheses, okay? So it's just minus that entire numerator. Okay, so from here, go and try it. You're going to distribute this negative, combine like terms, factor, and simplify. Go ahead and give it a try. All right, so we have the x squared, distribute that negative, so we have minus 3x minus the 28. All over x plus 4. We're going to try to factor, so it means I want two numbers that multiply to negative 28, but add to negative 3. My leading coefficient is 1, so I can jump to the shortcut. Two numbers that multiply to negative 28, but add to negative 3 are going to be negative 7 and 4. So I'm going to put in minus 7 and a plus 4. Do you see anything that cancels out? Yeah, we got the x plus 4 on top, x plus 4 on the bottom, leaving me with x minus 7. In this case, you do not have to put the over 1 just because something over 1 is just the exact same thing, okay? It's not like the last problem where we had to leave that 1 up top. So our final answer just is x minus 7. All right, next one. Do we have common denominators? We do not. Okay, so off to the side, go ahead and try it. Tell me what the factors are, and then try to figure out what you're going to multiply each fraction by to get your common denominator. Go ahead and combine the numerator and see if you can simplify. Okay, try all that, and then hit play when you're ready. Okay, so 9a is 3 times 3 times a. 6 is 2 times 3. A squared is a times a. Let's go ahead and circle what they have in common. So they have the 3 and an a. This is what they have in common. So remember, we aren't going to consider those in our missing factors because they both share those factors, okay? So now I went ahead and rewrote it with some space. So I look at the 9a and I go to the opposite one, which is 6a squared. I look for the missing factors, which are 2a. I multiply the top and the bottom by 2a. I go to my second set. I have 6a squared. So I look at the other one and I can see I'm just missing that 3. So I multiply by 3 over 3. In my first one, I now have 4a over 9 times 2 is 18. A times a is a squared. Minus 5 times 3 is 15. Over 6 times 3 is 18. And we have that a squared. I have common denominator, so I can combine 4a minus 15. And there's nothing that I can factor, so I'm done with that one. All right, number 10. Go ahead and give this one a try. Let's see how you do. So just to get you started, you'll want to go ahead and factor both of the denominators to figure out what they have in common, multiply each piece by the other one, and then you're going to have to do something with that negative, right? So remember how we had to distribute? You're going to have to do that again. Okay, so go ahead and give it a try. Hit play when you're ready. Okay, so x squared minus 9, that's a difference of squares. So we have x plus 3 times the quantity x minus 3. 5x plus 15, you can pull out a 5, leaving you with the quantity x plus 3. They have the x plus 3 in common, so you go ahead and rewrite it with the space in between here. And the first one, I'm looking at the x plus 3 times x minus 3. So I go to the other one, which is this guy here, and I see that I'm missing this 5. Multiply by 5 over 5. Now I'm looking at the 5 times the quantity x plus 3, so I go to the opposite one, and I see the factor that I'm missing is x minus 3. Now on the bottom, you can see I have the common denominator. We have the 5, we have the x plus 3, and we have the x minus 3. Up top, x times 5, we get 5x. Minus the 2 times the quantity x minus 3. Okay, so we didn't make it this far. Go ahead and hit pause and try to finish it off here. So remember, you just want to distribute. Okay, so I went ahead and distributed. So I have a 5x minus 2x plus 6. I can combine like terms, and I get 3x plus 6 over that same denominator. Now on the top, I can factor this a little bit, right? I can pull 3 out. So I'm going to have a 3 times x plus 2 and there's nothing else I can factor. There's nothing that cancels out. So in this problem, we're totally done. Let's just try 2 more of these for today, okay? So here's problem number 11. Let's go ahead and try number 11. Go ahead and hit pause, give it a try, hit play when you're ready. Okay, and this one, do they have any common factors? They do not. Okay, so in the x minus 3, we go and we look at the opposite one to see what we're missing, and we are missing this entire x plus 1. And in the second one, we are missing this entire x minus 3. But now we do have a common denominator of x minus 3 times the quantity x plus 1. Up top, we have x plus 2 times x plus 1. And then minus, now there is a lot going on here, okay? We have this entire x minus 4 times x minus 3. But what I'm going to do is I'm going to put in brackets because it's going to look crazy with so many parentheses. Let me show you just with the parentheses first here. Okay, and then from here, a lot of people would just put another set of parentheses to make sure that they distribute that negative later. I'm going to put in its brackets. Brackets are just kind of like super parentheses so that we can see in the order of operations. Let's do this FOIL before we even worry about distributing this negative, okay? So what I want you to do now, if you haven't done it already, go ahead and FOIL out this whole first piece, okay, and then FOIL out this whole second piece. And then if you're ready, you can go ahead and try to distribute that negative, combine like terms, and factor. Okay, go ahead and try that. Just mainly I'm worried about the foiling part. Okay, go ahead and give it a try. Okay, so we have first is x squared. I'm gonna do these next two in one step just to see if we're ready for that. We have outer and inner, right? So plus an x plus a 2x. So I'm just gonna write plus 3x. It'll just help me not have to write so much because the less I have to write, the less of a chance I have of writing down a number or a sign wrong. Okay, so I have plus the 3x, and then finally plus 2 minus, just so I don't lose anybody, let's just leave the super parentheses, leave the brackets, and just FOIL that inside piece there. So we have first is x squared. Again, let's combine the outer and the inner. So outer is minus 3x minus another 4x, so minus 7x plus 12. Now, what I see a lot is people are like, oh, now I know what to do. Now I have to distribute this negative, and then they totally forget that this was a giant fraction, and they just start showing the work for just that part, and they forget to carry down that denominator. So make sure with every step that you're writing that this is equal to this is equal to this, bring down that denominator with it, okay? I know it's extra writing, but it really is mathematically important. Okay, so we have our denominator. So now let's go ahead and distribute that negative. So we have a minus x squared, a plus 7x, and a minus 12. let's go ahead and combine like terms. I have an x squared minus an x squared. So I don't have any x squareds. Okay, any x's? Looks like we have a 3x and a 7x, so it's 10x. And then I have a positive 2 and a negative 12, so it's going to be a minus 10. Remember, bring down that denominator. And now we look to see, is there anything we can factor? And we can pull 10 out, leaving me with x minus 1. And there's nothing else that I can factor. Nothing that will cancel out. So that is my final answer. All right, cool. Let's try just one more. Oh, this one looks different. Look at that, a minus 2. What are we going to do now? Think of this. Let me help you set it up. We have x minus 1 over x plus 5. Think of this as minus 2 over 1, okay, because you can put anything over 1, right? So 2 over 1 times something, okay? So if you need to write out the factors, the 1's not going to have any. Try to figure out what you're going to stick in there to multiply by. Go ahead and try to do that. Let's see how far you can get. All right, so the x plus 5, if you go look at the opposite one, it's just missing the factor of 1, but technically it's not missing it, right? Because everything you can multiply by 1. 1's a factor of everything. So we don't have to multiply that one by anything. This one, though, we go to the opposite. We see that we're missing the x plus 5. So now our common denominator is x plus 5. And on the top, we have x minus 1, and then minus that 2 times the quantity x plus 5. So order of operations, what do I do next? I get a lot of people that see, let me show you and then I'll erase it. They see this minus 1 and a minus 2 and they do that first. That's not good, okay? Because remember, in order of operations, you want to multiply first. So we're going to distribute that negative 2 first. So I'm going to have x minus 1 minus a 2x minus 10. Bring down the denominator. Combine like terms, we have an x minus 2x. I get a minus 1x, or just minus x. A negative 1 minus 10 would be a minus 11. All over, common denominator ends up being that x plus 5. Nothing I can factor out or simplify. So we are totally done. Awesome. Good job today. I hope you have an awesome day.